You can find the full documentation for this kit on the kit's documentation page. Here are the components included in this kit, such as PCB, resistors, LEDs, potentiometer, LDRs, and a transistor. This is the circuit schematic of Dream Beam. Here you can see the potentiometer is a part of the voltage divider and can control the voltage drop on LDR, which itself is dependent on the light that it receives. The LDR is placed at position R5. When the light hits the LDR, the resistance of LDR decreases. This means there is not enough voltage at the base of the transistor Q1, keeping the transistor off. When the light source removed, the resistance of LDR increases significantly. This raises the voltage on the terminals of LDR and as a result at the base of the transistor, allowing current to flow and turning the transistor on. When the transistor turns on, current flows through the collector and LEDs turn on. This kit uses two resistors, 470 ohm, 1 kilo ohm. Depending on the kit, they may have 4 or 5 color band resistors. This is the 4 band color coding for 470 ohm. This is the 5 band color coding for 470 ohm. This is the 4 band color coding for 1 kilo ohm. This is the 5 band color coding for 1 kilo ohm. Start with two 470 ohm resistors. Next we move to 1 kilo ohm resistor. Place the components in their place, bend the legs at the back, solder them, and trim the excess leads. In this kit, the LDR is labeled as R5 and forms part of a voltage divider that controls the voltage on the base of transistor. The LDR is not directional, so it can be placed in either direction. In this kit, we put it at the back of the PCB since it would fit well with the structural kit. Insert the component in place, solder it, and trim the excess leads. Here we are soldering the potentiometer of the kit. In this kit we are using a 100 kilo ohm potentiometer, which could be identified by 3 digits of 104. The way to translate 104 is digit 1 and 0 translate to 1 and 0, and the digit 4 indicates leading zeros, or 10 to power 4, which translates to 100 kilo ohm. And here you can see other examples of translations of the 3-digit value. This is the schematic of the kit, and here is the potentiometer in the circuit, and this is where it should be soldered on the PCB. Mount the potentiometer in its place and solder its legs at the back. Here you can see the potentiometer has 3 legs. It has to go to the spot called pot 1, POT1. Bend the legs slightly at the back, then solder the legs. Next, we move to soldering LEDs. This kit has 2 LEDs connected to the collector of the transistor. LEDs have polarity, so they have to be installed in the correct direction. There are a few ways to identify the polarity of LEDs. The longer leg is positive, the shorter leg is negative. Some LEDs have a flat edge on the LED body, which usually marks the negative side. The most reliable way is to look inside the LED. The shorter connector is the positive way. Install the LEDs in the marked positions, solder them, and trim the leads. In this kit, we use an NPN transistor that acts as a switch controlled by the LDR. When the transistor is on, a small current at the base controls a larger current flowing from collector to the emitter, which powers the LEDs. When installing the transistor, make sure the flat side of the transistor matches the flat side printed on the PCB. Insert the transistor, solder the legs, and trim the excess leads. Make sure the flat side of the transistor matches the flat side printed on the PCB. Power connection. Next, we move to connecting the power connect. Connect the USB power connector. The red wire connects to positive and the black wire connects to negative. Solder the wires and trim any excess wire. Test the adjustable Dream Beam night light. Connect a power bank using a USB-C wire. This is the potentiometer that you can adjust the sensitivity of the Dream Beam. Turning to the left, it increases the sensitivity. Turning to the right, it decreases the sensitivity. Cover and uncover the LDR. The LEDs will respond to the amount of light detected by the LDR sensor. You can adjust this sensitivity by adjusting the potentiometer.